back into systems of equations. So we've already done graphing, solving systems of equations by graphing. That's when they intersect, one solution, parallel lines, no solution, same line, infinitely many. So there's another way we are going to solve systems of equations, and that's the substitution method. So when you do the substitution method, it is a method of solving systems by substituting equations within one another. Okay, well, now that you know that, good luck. Let me know how it goes. No, that sounds like a lot of this. So, of course, I put in steps to solve by using substitution, so read them. If you get confused and lost in your homework, go back and look and make sure you're following the steps. So step 1, it says solve one equation for x or y. So before, when we're graphing, we always put it in y equals mx plus b form. But in substitution, that's not, getting y by itself is not necessarily the best thing to do here. So remember that. It doesn't matter, x or y. So step 2 is we are going to substitute this expression into the other equation and solve for the variable. And then step 3 is we are going to substitute your answer into the revised equation from step 1 and solve for the other variable. Well, that sure made it crystal clear, didn't it? Okay, let's take an example. All right, now that you have your steps written, I'm going to erase mine and move up a little bit. So let's look at example 1. They are both, y is already by itself in both of these situations. So what it means by substituting one equation in for the other is, since this one, y equals 4x minus 1, is already solved. It's by itself, okay? I want you to think about this. If I'm gone, if I'm gone, who is my substitute? So Mr. Douglas Austin Weeks has been my substitute lately. So here I am, and here is Mr. Douglas Austin Weeks. That's what the first day is, right? Well, the next day, I'm not here. I'm gone. Y is gone out the door, but who has taken my place? Mr. Douglas Austin Weeks. So I'm going to substitute Mr. Douglas Austin Weeks in for me and finish out what I'm doing the rest of the day. Do you see what happened there? I substituted that value. So here I am by myself, and the next day, I'm gone out the door, and Mr. Douglas Austin Weeks comes and takes my place. And now, when we solve equations, we've only solved where the variable has to be the same. So the reason I need to do substitution is because I need to get my variable to be the same so I can solve it. I can only solve if my variables match here. This makes it possible for me to solve this equation. I can solve for x. So let's go ahead and solve it. So to solve for x, remember that was unit 3. We solved it. So subtract 2x on both sides, additive inverse. 2x minus 1 equals negative 5. Add 1 to both sides. 2x equals negative 4. Divide by 2, and x equals negative 2. All right. So there's negative 2. But I need this value. So step 3 says, substitute my answer into the revised equation, into this equation, and solve for y. So let's go back to the original equation right here. Y equals 4x minus 1. And now I know that x is negative 2. So remember back in the first unit where we evaluated for certain things? That's what we're doing here. So now I'm going to substitute in negative 2 for x, and that's going to allow me to solve for y. So I get negative 8 minus 1, negative 8 minus 1. That makes that y value negative 9. So negative 2 and negative 9. That's how I get that. And I can always check my answer. So if I plug in negative 2 here, negative 2 minus 1 is negative 9, which checks out. And if I plug it in down here, for x is negative 2, so negative 4 minus 5, negative 2 minus 5 is negative 9 for that one, so that equation checks out. So these lines, if I were to graph them, would be intersecting, and they would intersect at this point right here. Okay, that's number 1. Let's take a look at number 2. When it's given to me like this, I don't need to do any work. Step 1 is done for me. Y is already by itself. So again, here's me. Here's my sub, okay? Now let's look at this next equation. Remember, y is me. Everything else stays the same. So 2x stays the same, this positive stays the same, this 3 value stays the same, but y's gone. So in place of y, I'm going to put 6x. And then my equal sign stays the same and negative 20 stays the same. Now, this equation right here, my variables match. Remember, I have to have matching variables for me to solve. I can only have one variable be the same. So now I'm going to solve. 3 times 6x is 18x. And when I combine them together, I get 20x equals negative 20. Divide both sides by 20, and x equals negative 1. So there's negative 1 for x, but I'm still missing y. So what do? I take this equation, my original equation. Actually, it doesn't even matter which equation. I always just take the easiest. So I take my original equation, y equals 6x, and I plug in negative 1 for x. And so now y equals negative 6. So now I have an x value of negative 1 and a y value of negative 6, and I can always check my answer. Okay? All right, let's do number 4. So now it has x. So again, it doesn't matter if you get y by itself or x by itself. You just need to get a variable by itself. And in this case, it's already done for me. They've gotten x by itself. So awesome. So here I am, and here's my sub. So the next day, everything else stays the same. 2 stays the same, but look, x is gone. I'm gone. Who takes my place? 4y plus 7. And because it's a binomial, I want to put it in parentheses. So 2 comes down, x is here. That's my sub. So minus sign stays the same, 6y stays the same, equal sign stays the same, and 12 stays the same. Now I can look at my equation, and I've only got this, I have the same variable throughout, which is good. That means same variable is solvable. So now I'm going to distribute 8y plus 14 minus 6y equals 12. Combine like terms to get 2y plus 14 equals 12. Subtract 14 on both sides, and I get 2y equals negative 2. Woo! And then divide by 2, and then y equals negative 1. So now I'm going to give my answers in ordered pair. So y is negative 1. So watch this. I take my original equation, x equals 4y plus 7. And now for me to solve for x, negative 1 is my value for y. So 4 times negative 1 plus 7 is negative 4 plus 7, which is 3. So now x equals 3. So 3 and negative 1. Excuse me. And I can check my answers there. Okay? I know I'm talking fast, so pause it and go back to make sure you understand. All right, now let's look at number 5. There is no x or y by itself. So now I am in charge. I get to decide what I want to get by itself. Do I want to get x by itself? Do I want to get y by itself? Here's the easy thing to do. You look where your coefficient is 1. The coefficient's 2, coefficient's 1. Coefficient 5, coefficient 3. So on these, you want to be smart about what you're doing. If your coefficient is 1, that means when you get your variable by itself, if I got y by itself, I don't have to divide anything to get y by itself. That's why I'm choosing a coefficient of 1. So on number 5, I'm going to get this y by itself. On number 6, I'm going to get this y by itself. On number 7, I'm going to get this x by itself because the coefficient's 1. On number 8, I'm going to get this x by itself. On number 9, I'm going to get this y by itself first. And number 10, I'm going to get this x by itself. And then number 11, I'm going to get this y by itself. So the first goal is to look in step 1, and which variable are you going to get by itself first? I'm choosing the variable where the coefficient is always 1. That's what I'm doing. So let's go back up and look at number 5. So, on number 5, if I want to get y by itself, what do I need to do? I subtract 2x on both sides, right? Additive inverse. So now y equals negative 2x minus 2. Now my problem looks just like those up there. Y is by itself, so here I am. Here's my sub. So the next day, the one I haven't manipulated, the second one right here, the one I haven't manipulated, Everything looks the same. 5 looks the same. X looks the same. Plus looks the same. 3 looks the same. But y is gone. I'm out. So who takes my place? Negative 2x minus 2, close parentheses, equal looks the same, and negative 8 looks the same. And I will look at my equation. All my x values are the same. I have all x's, so that means that's good. So now I'm going to distribute and solve. So 5x minus 6x minus 6 equals negative 8. When I combine like terms, I get negative x minus 6 equals negative 8. Add 6 to both sides, and I get negative x equals negative 2. Can't have a negative variable, so I divide by negative 1 or multiply, it doesn't matter. Just flips my sign. So x equals 2. So now x equals 2, and now we just solve for this y value. So I can take any of these three to solve for y. It doesn't matter. I'm going to take this one because there's a lot less work. So I have y equals negative 2x minus 2. I know that my x value is 2. So negative 4 minus 2 is a negative 6. So y equals negative 6. That's how I get those values. Okay, let's do a couple more for your journal. Make sure you're writing all these. Let's go, let's do number 9. Number 9, because we've not used one where I had to solve for down here first. So on number 9, I'm going to get this y by itself because the coefficient's 1. So to do that, I subtract 2x on both sides, and I get y equals negative 2x plus 18. So now, I look at the equation that I haven't manipulated, that top one. And again, I'm y, that's me, here's my sub. So everything looks the same. 6x looks the same, plus sign looks the same, 3 looks the same. The only thing that's different is that y is gone, and who takes my place? Negative 2x plus 18 takes my place, and then equal looks the same, and 54 looks the same. So now I distribute 6x minus 6x minus 40, no, that's not right, to 54. Minus 54 equals 54. So 6x minus 6x cancels out. And then if I get 6x plus 6x cancels out, and I'm left with negative 54 equals 54. So, oh, but you know what? Hang on, I knew something wrong. Sorry. When I distribute out my 3, let's do that again. Sorry. 6x minus 6x plus 54 equals 54. When I distribute out my 3, it's positive. So my 6x's cancel out, and I'm left with 54 equals 54. Well, remember when we did that before, what does that mean? Same numbers, my variables cancel out, special case, infinitely many solution. So if I were to graph those, what kind of lines would those be? It would be the same exact line. That's what infinitely many solutions means. Same exact line. So that's what number 9 is. And then last one we're going to do together is number 11. So when I look at number 11, I'm going to get this y by itself. So to do that, I subtract 3x on both sides. And I get negative y equals negative 3x minus 8. I can't have a negative variable. So I multiply everything by negative 1. All that means is my signs change. So now this becomes positive, my 3x becomes positive, and my constant term becomes positive. So now I manipulated that one. Here I am, and here's my substitute. So this guy, everything stays the same except y. So 5x stays the same, positive stays the same, 2 stays the same. The only thing different is in place of y, I get 3x plus 8, close parentheses, equals 5. And now I distribute 5x plus 6x plus 16 equals 5. 11x plus 16 equals 5. Subtract 16 on both sides, and I get 11x equals negative 11. So 11x equals negative 11, divide both sides by 11, and x equals negative 1. So x is negative 1. To solve for y, I can take this equation right here, y equals 3x plus 8. I know that my x value is negative 1, so negative 3 plus 8 is 5. So y equals 5. Okay? So if you have questions with substitution, come and see me, but hopefully that video explained how to do it. When you get lost, look at your steps and then go back and maybe slow down the video so you can really understand where I'm plugging in those values. If that still doesn't make sense, come by and see me.